Hello, we're back with some more Project Euler here in C. Showing a little synopsis of how you solve the problem and why it works. But yeah, we have problem 6, the sum square difference. The sum of the squares of the first 10 natural numbers is 1 squared plus 2 squared plus, plus 10 squared equals 385. The square of the sum of the first 10 natural numbers is 1 plus 2 plus 3 through 10. You square that number, you get 55 squared. You add these numbers, you get 55. Square that equals 55 squared equals 3025. So, hence the difference between the sum of the squares of the first 10 natural numbers and the square of the sum is 3025 minus 385, 2640. Find the difference between the sum of the squares of the first 100 natural numbers as opposed to the first 10 and the square of the sum of the first 100 natural numbers. So yeah, this one's also pretty short and it won't take very long. But we're gonna have, start off with our few variable declarations here. We're gonna have sum of the squares. We're gonna have square of the sum. And we're gonna have a difference. We're just going to initialize them here. We'll initialize x to 1, why not? We don't need to declare int again, of course, that'd be bad. And then we'll initialize the other ones here. I know you missed me initializing like this, so I had to bring it back. And not do that. Alright. We're just gonna set those to 0. X will be 1, we'll be looping through. The first 100 natural numbers being whole number integers, 1 through 100. So we're gonna use the for loop because it'll loop through it for us, yeah? Start with x1, we'll do x less than or equal to 100. And x plus plus, because we don't use plus plus x here. That's heathen speak. You don't want to do that. But for the first 100 natural numbers looping through, the sum of the squares of those numbers, or well, the variable sum of squares, starting at 0. For every iteration, we're gonna add x times x. This will be x squared, 1 through 100, 1 squared plus 2 squared plus 3 squared, so on, so forth, up to 100 squared. So that'll give us the sum of all the squares. And we'll have the square of the sum. Or at the moment, it'll just be the sum. But right now, square of the sum will just be equal to itself plus x, which this will add 1 plus 2 plus 3 plus 4 plus 5, so on, so forth, up to plus 100 into that variable. So after we're through with that loop, 1 to 100 of the natural numbers, we're going to take our sum square there, we're going to have it equal to itself times itself. Now you may be able to do like a, the caret 2. May be able to do that. You might need the math library for that, not too sure. But this works and it's simple, so I figure, might as well keep it pretty simple. We square it at the end to equal, the square of the sum. That's why we called it that. And the difference then being the difference in them. Now the square of the sum will be more than the sum of the squares, so we don't want a negative number, and because that will be wrong. We want this, the difference in them. Square of sum will be the higher number, so we're gonna take the difference that way. And then we'll just print the difference. And that should be all that needs to be done. You can separate out a little bit if it's easier to read. But yeah, that's all you need there. I already solved it, but we'll see if we get the answer again. If not, then something went terribly wrong, and we don't want that. But yeah, thus we get 251,64150, or 25,164,150, and that be the answer. So yeah, that's really all you need for this one. It's pretty short just like the last, but anyway, Thanks for watching. I'll see you on the next one. We'll go over problem 7, 10,000 first prime. I'll see you then.